Today, we're going to be talking about architecting knowledge organization infrastructure. And I'm going to start off with some more kind of theoretical background about how I think about the problem and then move into practical examples predominantly from Metagov. Metagov, as Anessa just mentioned, is a US-based nonprofit focused on digitally mediated self-governance. So my obligatory bio slide, I have a PhD in electrical and systems engineering from the University of Pennsylvania. I'm the founder and chief engineer at BlockScience, board member and research director at Metagov. I am a trustee of a data trust called Superset, and I'm a lecturer and advisor at a variety of different organizations. And as Anessa mentioned, I'm a advisory council member at NumFocus, which is particularly relevant to this community. How I got here today, I was at the NumFocus Project Summit talking about some work that we've been doing at Metagov around knowledge organization infrastructure, which is based on some ongoing research and development and in-house implementations and client projects at BlockScience. And so there's a lot of organizations kind of contributing to and experiencing the benefits of this research, but I really felt like this community could benefit a lot from thinking about how we both design, implement, operate, and govern our knowledge infrastructures. And so I decided to take that lightning talk and blow it out into a full talk, and that's what we're going to do today. So for starters, I'm going to kind of review what I think of as architecture and keeping in mind that I'm a systems engineer, not a software architect, which means my experience is in architecting things like robots, business decision systems, and a lot of elements that contain, or systems that contain more than just software elements. So they can use human and operational processes. They can include legal components, even if I'm not the one provisioning the specific legal items. That includes licenses and contributor agreements, legal entities. And you can imagine that these kinds of systems, when they involve technology and humans, that they have a lot of components. What I want to emphasize here is that architecture is about the way those components are arranged in relationship to each other. And in fact, the same components can produce lots of different behaviors depending on how they're organized relative to each other. And so a lot of this discussion today is going to focus on using almost out of the box components, at least wherever possible, and just organizing them in new and interesting ways that achieve our goals from a behavioral perspective. So I'm going to start off by doing a little bit of theory, which I hope you guys appreciate. So there's this concept of an institution, which the sort of canonical definition from Douglas North is a humanly devised constraint that structures political, economic, and social interaction. I'd like to compare that or contrast it with infrastructures, which are the basic physical and organizational structures and facilities, e.g. buildings, roads, power supplies needed for the operation of a society or enterprise. And part of the reason I like to emphasize this is these are actually very similar. And if we think about it from the perspective of our own organizations, we establish practices and we develop infrastructures, and the infrastructures enable, facilitate, standardize, automate, and decentralize the various practices, the human constraints and activities. And those practices actually are used, they include the use of, the operations of, the monitoring, the maintenance, the governance of those infrastructures. And I think this is especially true when we're talking about digitally mediated organizations where the infrastructures in question are technical. But I would not exclude from this literal physical infrastructures as well. As a systems engineer, I sort of attack this problem through something like a standard engineering validation and verification V, but I've broken it down into something that's a little more commensurate with a kind of startup or software development mindset, where we are thinking about narrative models in terms of storytelling, but also requirements and user stories and theories of change. And then we digest from those more formal requirements, designs, metrics for testing. If you're doing test-driven development, your tests might be the best representation of your intended design. But ultimately, those models have to be compared back against the human expectations. And there's always a little bit of a gap here just due to the legibility difference between people's stories and formal specifications. Of course, formal specifications are the things we use to implement, and implementations can be verified against those specifications. But implemented systems also have users and operators and experiences produced by the user operation of those systems. And of course, we get validation when we look at whether or not the system is producing the intended outcomes. Ultimately, we're comparing back and forth the users or operators' experiences against the narratives, and in fact, users' experiences and their own commentary about those experiences produce new narratives, and you end up with a kind of closed loop system interacting between the sort of technical, potentially very complex systems and the desired experiences and the lived experiences of the users and operators. And we view these systems as successful when we can actually align people's expectations. And that doesn't mean that everyone always gets everything they want. The real world is full of trade-offs, but ultimately we're setting expectations that can be met and meeting them. And then continuing to maintain that alignment is tantamount to governance. In systems engineering, we talk about architecture and a variety of different levels of abstraction, and I think there's often a lot of confusion by jumping between layers. So as a sort of high-level overview, conceptual architectures are really just like ideas doing and kind of what the subsystems are. Functional architectures break systems down into like components that actually do something. So they may take inputs and produce outputs. They may fulfill key functions within a data supply chain, or otherwise meet some express need, including some subsystems meeting the needs of other subsystems to create an overall system that can and deliver on a preferred set of behaviors. You get into logical architecture when you start to specify how. The difference here might be a functional architecture might call for a model that takes a certain set of features and returns a certain set of labels, but a logical architecture starts to specify like what kind of model to use. Are you using random forests or are you using logistic regressions? And then as you move into physical architecture, you're concerned with the actual specific implementation. So in my, machine learning model example, you might be like using a very specific model from a scikit-learn package with a specific, even down to a specific instantiation of that. The more specific, the more concrete or literal you get, the further you are into the physical architecture. And then obviously there's ultimately the thing itself. But working your way from conceptual through functional and logical to physical is how we go about architecting particularly complex things, especially when there are aspects of the functional architecture that are not actually implementable. They just exist in the world. And this is commonly the case when you're dealing with systems with humans in the loop, when you're concerned with a group of stakeholders who are directly participating and the system that you're architecting accounts for both their contributions and their expectations and needs. So what is knowledge organization infrastructure? It's systems, tools, processes, rules, governance mechanisms that enable the collection, curation, management, sharing, and utilization of knowledge within a specific context. It encompasses both the technical and social components required to ensure that knowledge is discoverable, accessible, reliable, actionable, basically that it serves the needs of its stakeholders. And so the key here is that we're talking not about just like a data lake or a particular data commons or pool of data, but actually its incorporation into a specific operating context, specific group of people doing a specific thing. That means that they have specific desires, wants, and needs, and they have specific limitations, available attention, resources to spend on the effort of maintaining and using that knowledge. And so I'm going to briefly review some material from a paper called Why Is There Data? It's by David Sisson and Alon Ben-Meir, and David's actually in the audience. So if I grossly abuse it, he should interrupt me and tell me that I'm wrong. But I'm going to start with this closed loop system model, which basically shows a feedback loop from what you can think of as raw serialized data collected from some location out in the world, whether that's a physical sensor or an online platform. We're basically suggesting that this is low-level event data of some kind. It's raw facts. And raw facts go through something we refer to as information processing, and this will be a pretty traditional data flow, which I'll review in a moment. But it is going to be recognizable to everyone in this community, I think. Where we're focused today is actually on knowledge processing and sort of understanding how we move from an information processing way of reasoning on to a knowledge processing way of reasoning, and how that serves understanding, and that understanding is still, at least in my opinion, the province of humans, whether that's kind of humans in a group or individuals. This is how we take knowledge, we take it into context, and we render decisions, and those decisions then affect the world. Of course, then the consequences of those effects on the world may feed back to us through our sensors, through our observation. But at the end of the day, this ongoing loop is something that we can think about as having an effectiveness if we're able to produce desired or intended effects, which is distinct from something like how efficiently can we process data. And I think a lot of the times when we talk about intelligence, especially artificial intelligence, there's a tendency towards focusing on efficiency, scale, throughput, et cetera, but not necessarily as much focus on like the quality of the outputs and whether they are actually having the intended or the desired effects. So kind of traditional information processing, we acquire data, we put it in a raw store, we conform it, which means we standardize it to a particular schema. We may have a variety of different data sources, so we can enrich records with data by joining and connecting fields from other data sources. We can aggregate, maybe we group by and compute some statistics. Maybe we learn some machine learning models. But at the end of the day, what we're pushing out is something that is higher level. We've gone up. We've said, hey, all this low-level data without some sort of confirmation, enrichment, and processing isn't super useful for us just yet. So as those serialized data sets come out, we can think of them as feeding into knowledge processing. And knowledge processing is fundamentally different from information processing under this model because it's circular. It is not idempotent. It's not something where we'd expect the same results. If you apply the same operation to an object, you're going to get a new object. The kinds of operations that we're interested in are, compose, so combining things, decompose, breaking them down, kind of decorating, which is a form of adding additional information, mutating, so literally just revising or editing, producing diffs, curating, which may involve filtering certain things out, searching or discovering new objects, or even generating new objects. And you can see there's a feedback loop baked in here, that this stage is meant to be more circular. And we'll come to a concrete example in a moment that I hope will elucidate the difference. But this still is feeding into a process that we're referring to as understanding. And you can think of this as a more deliberative process. It still involves knowledge objects, so papers, open source software projects, again, these higher order objects that aren't just the data. The data may have been collected, analyzed, plots might have been made. You're consolidating that information into things that describe what's going on or interpret it and kind of render it ready for input to a human sense-making process. And so this diagram here is a derivative of some early work on a concept called computer-aided governance, where we take principles of data-driven decision-making in business and apply them to participatory governance. So you can imagine having like a data science team or a participatory citizen science team within a community doing work to make sense of what's going on and to help make policy, make rules, make decisions. And so here we see the knowledge objects as the inputs to the understanding process, and that deliberation and discussion process can itself produce knowledge objects. So if you do an analysis or a scenario plan and you share it with your other community members as support for a proposal that you're making, whether or not that proposal gets passed, that analysis or that proposal can effectively be recorded, serialized, exist and stored as a knowledge object. So I guess I should probably jump back quickly and say that reassembles here. So those three slides are these three boxes, orange, yellow, and green. And in effect, together, they form a process that results in action in the world and information then incident on the system again. Now, I want to point out that this isn't a particularly novel idea, especially for communities steeped in open source. I would argue that an open source software project is already a pretty good example of this, and you can start to see some of the pieces. We're like, all right, well, we have some of the infrastructure of organization here. We have code of conduct. We have a contribution guidelines. We have a variety of documentation about the organization itself. We have semantic versioning for releases, software licenses, and so on. And so what I'm talking about today is how to move beyond something that is pretty well contained within code. I would argue that a GitHub repo or a GitHub organization combined with a little bit of extra institutional wrapper, for example, a nonprofit fiscal sponsor like NumFocus, provides most of the core needs of an open source project. And to the extent that there are gaps, people kind of fill those gaps in by, instantiating maybe private communication channels where they need them. There was some interesting back channeling when things go wrong, like the period when Git was one project got a GitHub takedown notice last year. I think it was SymPy, and there was like a whole kind of human response to make sure that that got rectified and it got back up. And I would also consider that to an extent part of the social system, but not something that you can specify a priori. And so as I move into the rest of the talk, I'm going to be talking about how I think about this problem when we're dealing with communities that are a lot more heterogeneous. They have more stakeholders, more diverse work products, more diverse working environments, really kind of pressing on the challenge of infrastructuring, with actually some of the insights taken from experiences in open source software development, where I think the best practices around managing contributions, using workflows like Git and establishing specific workflows for specific projects, and including how one becomes a contributor with the authority to, say, merge a pull request, et cetera, are all quite good. As we move beyond the environment of managing code, where like a particular software project is the thing we're managing, I think it gets messy and hard pretty fast. So one way to think about the conceptual architecture here is to do a little bit of a layering. So I like putting the social and the technical view side by side. And so I look at the overall system as being fundamentally human. So when I say evaluate emergent properties of socio-technical assemblage against mission, vision, and values, I'm basically allowing for a intervention over the system itself. So if what's in the small box that I've labeled KOI is a set of practices and technologies, then when you account for the organization and its governance processes, the thing that I've labeled OIKOI, which is organizational integrated knowledge organization infrastructure. I know it sounds like a mouthful. It's actually because oikoi is a Greek root word of economics and refers to household, and so it's kind of a like Easter egg inside joke thing. But anyway, we have our integrated system that incorporates the entity and the human governance processes. And then we have this object, which contains any number of interfaces, logic and rules, databases and integrations, or various kinds of data stores ranging from literal databases to web platforms, Airtables, Google Sheets. You get the idea. But when we look at this from a social perspective, the interfaces are the place where you produce the experiences. The logic and rules are the place where you embody policies. And the databases and integrations, they're the places that you sort of entrench ontologies. So basically practices, algorithms, and world models. And as someone who comes from more of a robotics background, I'm actually like pretty attuned to the fact that your world models are like important grounding. Like you can't write an algorithm that tries to implement something that refers to a concept that doesn't exist in your ontology. And the algorithms are the things that often produce the circumstances or the incentives within which the practices emerge. So it's actually quite difficult to work from the top down here. You really have to work from the bottom up. But then if you're off in your ontology, if you're off in your data models, your data dictionaries, the things that represent the concepts in your world, then you're also going to run into issues. And so one thing that we're really interested in knowledge organization infrastructure is ensuring a degree of flexibility in that base level. So you need enough consistency to render these systems interoperable or just computable over, stable enough that systems aren't breaking when you make changes, but you still want to preserve flexibility so that to the extent possible, ontologies can emerge from practice and therefore better fit the communities they're serving and adapt as those communities adapt. They grow, change, fork, merge, etc. So the kinds of systems that we've been working on, they have roughly this shape. We have a group of actors within an organization interacting with the system through a set of interfaces. What they experience is a consequence of both data and rules, and that technical infrastructure facilitates further action onto the world and reading, sensing information from the world. And we see humans as both following rules as well as potentially updating those rules and being able to interact directly with each other, sharing and learning from their experiences. And we've further moving towards a model where we can have multiple instantiations of this kind of, again, sort of conceptual architecture interacting with each other. And we see a lot of this at the social layer and at the technical layer. So you get social interoperability when you have common members of communities or when you have kind of discussions or negotiations, like if you're on a Zoom call or in a chat channel together, you're able to communicate kind of human to human. Especially if people have representative authority within an org, they can form partnerships, set up projects together, apply for grants together. At the technical communications layer, these are effectively data services. Like you open up an API, it has a specific set of queries that it will respond to. Maybe it has an access control regime, but you can have technical communications. Part of what we're seeing with the advent and the adoption of LLMs is a bit of mixing of this, where you could have a technical interface talking to a human or vice versa, and that opens up both opportunities and challenges. And some of what we'll get to later is attempts to wield that capability, but in like a careful and respectful way. The technology that we've been developing for this, it basically has the goal of being instanceable, governable, and interoperable. At this stage, I would say we have a bunch of bespoke instances, I guess technically 3 now, and some other folks that are interested. Still a little bit kind of a little bit of work. You have to have someone with a lot of knowledge who's been contributing to the project in order to do that, but we're moving in a direction where there'll be sort of software that's easier to pull and it's more realistic for someone to create their own instance, with the caveat that since most of what we're building is not actually software, it's glue for assembling things, it can be a little bit tricky. We're pretty excited about it though, and we're looking at breaking these down, the interfaces by the different actors that would interact with those interfaces, going all the way from instantiation to kind of the technical administration, through the sort of data governance and kind of tagging and curation, through the discoverability, kind of visualization and exploration, as well as kind of writing rules and adjusting the internal policy making within these systems, and finally kind of natural language chat interfaces. And as you see when we get to the concrete examples, there's quite a bit to it, but we're pretty focused on using out-of-the-box tools and combining them into kind of interesting assemblages. And now I'm going to come back to the point where we step out of the tech for a moment and think about the other aspects of the architecture. So these kinds of systems, they don't exist outside of the human world, but they still have to have an accountable party. And so I've labeled this blue box authority. And there's a couple of versions of this diagram floating around. I think in another one it says decision, but what I really mean here is like the decision-making authority. Do you, as an entity, have the ability to write agreements, to enter into them? Who is responsible for the behavior of the system? Because anytime we're getting involved with developing software, data products or services, it's really important to understand like who's responsible for that thing, that these technologies are not in and of themselves separate from the humans that are producing, operating, maintaining, and using them. And so that authority is an entity. And with the stuff that we've built at my firm, BlockScience has some things that we own and operate. Metagov, as a legal entity, a nonprofit, kind of owns and operates things. And in settings where there are projects that are too small to have their own entity, you end up with a fiscal sponsor or some sort of signatory with legal personhood. Again, Metagov, we fiscally sponsor a variety of projects that are run by research directors. At NumFocus, there's a bunch of fiscally sponsored projects. But in that case, then even though there are individual actors running the projects, there's still a kind of legal accountability layer associated with that fiscal sponsor. And so then we step down a level into policies. This is where we have licenses and other kinds of agreements. It could relate to what kinds of consents are required. In one of the examples later, we'll talk about IRBs. But for the most part, this is where we actually enter agreements. So you have to have the authority to enter them in blue, and then you enter them at the level in green. And this could mean following standards. It could mean entering into agreements to consume external APIs, maybe ones that you're buying, and so on. And then as we move down to administration, this is like the sysadmin layer. Like, sure, you might have a set of rules that say you're supposed to do certain things, but you actually have humans, practices, and technologies, say access control regimes, that are used to actually implement those policies. And it's important because if the authority is accountable for living up to the agreements they make, and the policy represents the agreements that have been made, then the administration is the follow through on that. And then finally, we get to the system. And here, the system is the actual information technology. It's the data in the database. It's the files in the Google Drive. It's the whatever the thing it is that you're actually interacting with. And we may have a variety of documentation, technical documentation as well. Again, the data dictionaries, the API specifications, possibly like service level indicators and other data like kind of about the system. And then at the level below, we have the various technologies that have been kind of assembled to create that system. And that's going to include your storage, your compute, transport, and then the agreements with any of the entities that you are, in fact, consuming those services from, because we're not just talking about software, we're talking about services, things that are running, which means that they exist somewhere. Their physical architecture includes a place where you can invoke them, and that each of their components have an implementation either internal to that data product or a service that data product consumes. So then we get to the question of like, how do we get from this general stuff to specifics? And this comes in part from my work with the data trust, where we're trying to figure out like, okay, sure, the devil's in the details, but like which details? What do we care about? Well, it turns out that we care about where the data is coming from. So like, what's the phenomena of interest? What is it a measurement of? And how is it collected? Things like, well, did it come from a chat application? Is it a social network? Is it economic data? Is it GitHub or Google Docs? Is it a forum discussion? Like, where did it come from? And what activities produced it? And so then we can ask, well, then like whose activities then? Like from whom? So if it's a forum, then it's pretty obvious who the authors were, at least up to the level, the strength of the identity within that forum. But in other environments, it can be less obvious whose data it is. I mean, you often see clauses in user agreements for applications that just basically say, by using this, all your data is ours, which is, not ideal, but it's the current state of the art in a lot of applications. And for this state, we're just like trying to be clear, like, okay, but like who did this come from, and what are their expectations, and what kinds of agreements are they party to? And to the extent that a user agreement that just says click wrap, by using this, you consent to all of these things and you didn't read it anyway. Like, I don't generally consider that to be a good model. It may be totally legal. It's questionable. And so that covers the first two bullets, which are the kind of from side. And then we kind of switch into okay, for what? And it continuing with the discussion of kind of click wrap, there tends to be a kind of, and we can use this for whatever we want as the parties collecting it. And again, kind of questionable. It seems more realistic, at least from an end user perspective, to constrain the expected uses of data to, like defined purposes. Like, is it being used by researchers, data stewards, other researchers, companies, nonprofits? Is it medical data? Is it being used by the, et cetera, et cetera. But what's important here is that although it is not commonly the case to distinguish what data that has been collected can be used for, it is something that one can do, and it's in fact much more realistic to do in smaller settings. So in these knowledge organization infrastructures, which are serving specific communities where it's actually the members of those communities who are the people the data is from. And to the extent that those communities and their partners are the people who the data is going to, there's a lot more room for kind of policies that say like, hey, you can only use this for that. And to the extent that you have a relationship with the entities that are managing that data, collecting it, using it, organizing it, you may be more willing to share data if you're confident that it will only be used for the things that you have said that it's okay to be used for. Right. So now I'm up to examples. This should be the fun part. I'm going to talk mostly about an organization called Metagov. In Metagov, we have a board of directors, we have an executive director, we have a kind of finance/operations manager that helps with the back office, we have a community manager that helps with our organization and kind of the activities, the seminars, the working groups, etc. And we have research directors. Research directors are volunteers like the board is, and they lead projects. Some are professors, some are entrepreneurs, but a variety of people who are kind of pushing the envelope within the scope of Metagov's mission to cultivate tools, practices, and communities that enable self-governance. If you're interested in the org, you can check it out. The metagov.org is the link. But we're going to be looking at knowledge organization infrastructure in Metagov for the rest of the talk because it gives us a concrete situation, an operating context to discuss things. And so within that operating context, we have some challenges, and I think those challenges are also opportunities. So Metagov includes people from all over the world, a mix of researchers, practitioners, and leaders of other organizations, diverse experiences and opinions, and that means great collaborations, but also debates and arguments. We've got a website, we've got a seminar with recordings on the Internet Archive, we've got a public Slack as a primary access point. There are lots of discussions in public channels, but they can be kind of meandering, kind of breadth first. Lots of discussions in private channels. They can be opaque. People might not even know about them. They're more like working groups, people working on projects, maybe don't want to be interrupted, maybe they're focused. But also, it's not clear to people that that's even going on if they're not there. It's kind of an in the room thing. And then we have project work that's both curated and emergent. So research directors are nominated and approved, but then are highly autonomous in their projects. They secure funding from government and philanthropic grants. And as a member, it can be really hard to keep track of the project portfolio, to know what's going on, where and how they can contribute. And you can see some aspects in common with the open source projects, but without the nice, clean, like locus of coordination in the form of like a GitHub organization or a Git repo. It's a lot more spread out. So some things the org started to do to try to kind of counteract that. So one of the first projects was something called GovBase. GovBase is a data set, and it's in Airtable. It's actually a bunch of different data sets. I believe it's licensed under Creative Commons. The point of contact is actually one of the founders of Metagov, Josh Tan. And it's administrated via working groups in Slack. Its access controls are managed through Airtable, and the system is really just an Airtable instance. And to try to answer some of these questions, like where's the data come from, manual data entry and or import from individual researchers, spreadsheets, or local data stores. It's primarily for those same researchers as a broader group, maybe because they want to look at comparisons between data sets. I think there's some secondary use cases around synergies between the data sets, and eventually it's going to be incorporated into this broader Metagov koi pond, which I'll talk about as I go a little further. But actually what I want to emphasize here is that this particular piece of infrastructure kind of got out over its skis. At the beginning, when it was a small group and it was only a few data sets, it was stewarded pretty well. But I think anyone who's tried to manage a database that in a non-database technology quickly realizes it can get out of control. And I sort of see GovBase as an example of something that was both very effective and eventually hard to govern. And so it may be better suited to stewarding data in other infrastructures. Another data set that is curated in Metagov is its members directory, opt-in and public. So it's actually displayed on the website. It's primarily managed by a community manager, gets pushed to the website via web developer, and it's largely part of the onboardings. So people join, they can be directed to, or a community manager will direct them to an onboarding type form. They fill out things that they're interested in, decide how much information to share about themselves. There's a private version of that data set, and there's a curated version of it that's actually on the website, and you can kind of scroll through it, and you can click on people's LinkedIn if they chose to share it, or see information about their other affiliations. Some of the more interesting, let's say, homegrown knowledge organization infrastructure in Metagov includes something called Telescope. It was originally developed under a grant that Ellie Rennie got. She's a professor focused on automation and society at RMIT in Melbourne. It's actually was developed to be consistent with her IRBs, and it is a set of bots that allow you to like if you're researching a community that exists predominantly online, you're able to give them a emoji telescope that will flag a message as being important. That triggers a flow where the person who wrote the message gets a consent and the ethnographers get a curation flow. And the result is it actually builds a data set that was partially developed by the community itself. So the community members in the Discord are actually participating in the process of determining what's important and organizing it for the use by the ethnographers, who would in turn, provide feedback, guidance, research papers, etc. There's a paper on a project called SourceCred that was written based on ethnographic research that included this bot. And today there's also a Slack version of this. And as we'll see later, we further integrated it with some of the other tools. But one of the reasons I like it is because it emphasized including the people who were discussing topics within these channels in the process of determining like what was relevant. Another pretty basic piece of knowledge organization is project cards. This is project documentation. Again, can be very difficult to wrangle with a particularly duocratic kind of community-driven group. But here we have on our website a variety of project cards. Our RDs, research directors, are theoretically required to write them. Arguably, we don't do as good of a job as we should, and we're increasingly supported by a project manager who helps make sure that they get generated. They're public. The kind of social pressure happens in the research directors group meeting, and ultimately the pushed content has to be added by the web developer. There's a lot of room for automation there, but for the time being, they're pretty simple. Basically, you're filling out a schema, making sure you answer a certain set of questions, providing a image, and then it gets uploaded. And the practical system here is the website itself, the project Slack channels, the Zoom meetings, as well as actually any Google Docs and content. But the content from the projects themselves is spread pretty wide, and we're not trying to aggregate or reproduce it. And again, I'll bring that up in a moment. So another thing that Metagov has is a curated collection of papers and blogs. This has been started, I want to say like 6 months ago. And a group of people in a working group in a Slack channel are like basically just filling in this Google Sheet and capturing the title and authors and a URL and some metadata. And then the checkbox on the left determines whether something has been ingested. Has it actually been brought into a database? Because the Google Sheet here is really more of an interface. It's not the data, it's not the core data. It's a way of referring to things and saying, hey, this belongs in our data set, and these things can be embedded. We can have vector embeddings for use with LLMs, and we also have we're in the process, I guess, of implementing the RID database, which is a graph database where you can think of it as a knowledge graph, but where the nodes in the knowledge graph are knowledge objects. Which brings us to reference identifiers. This is a piece of Python code that connects with Neo4j graph databases that's developed at BlockScience. It's under an MIT license. It's primarily Beneficent Dictator with Luke, who's the main developer, guiding development with contribution from peer review from other working group members. There's a weekly stand-up, and it's a GitHub repo with Python code and the kind of material for developing graph databases. And I think the most important part here, though, is plugins. And this is a thing where we need to get the nodes automatically. We don't want to be building these things from scratch. So you can curate at the graph database level, but you want to be scraping the content. And that ties back to the previous where, look, if the Google Sheet is something we know about, it's a knowledge object, then we can actually run a process that says, okay, go get all of these things and create nodes for them, as well as create vector store embeddings for them. And then finally, this brings us to the koi pond, which I think is the exciting thing here is organizing this stuff into a coherent system that supports accessibility and discoverability of Metagov's knowledge, of its local knowledge. Because again, it's pretty opaque, it's spread out, everybody's working in their own place, and we want to get to a point where you have UIs like the chatbot, you have search interfaces, you have other applications that you can build that hit these things via APIs. And for that, we have the vector store embeddings, we have the graph database, we have search, we have LLM inference via third-party APIs, and then the actual actuators and sensors, they're bespoke. And, we've been talking about them. The things I just shared with you were a bunch of the the current and future data sources that we're gathering from, and that the actuators actually at present are primarily the chatbot. Again, that's not that the chatbot's the end goal. It's just that that's the thing that people like to interact with. And so you can see on the right here an example of an interaction. This is from a testing channel, and this is Lee Eleanor DeSoto, and she's been working to help develop this project at Metagov amongst the other team members. And so here's a kind of high level, maybe a bit more cartoonish view of what's going on. So we have a bunch of data sources where we want to meet the members where they are rather than push them into new tools or workspaces. So the website is a thing that gets produced according to existing processes. Documents in Google Drive are produced according to existing processes with different, in some cases, many different groups of people. There's GitHub. There's lots of other things. Airtable is an example. We have the ability to then connect our plugins and run services that write to the RID graph database and the vector embeddings, and the koi API effectively orchestrates this. So it includes the ability to invoke the LLM inference, and in the future, potentially other services. And most people actually interact with this information directly via a chat bot in Slack. Keeping in mind that Slack is itself also a data source, and for reasons of managing consent, we have an instance of the telescope bot. So if your Slack data is being telescoped and is getting gathered, then it's not just going to be automatically done without you knowing about it. You'll get a DM, it will ask for your consent, it'll give you the option to anonymize. And so this is an example of a slightly more structured flow, or in a way, a place where we're trying to be very explicit about what people are and aren't contributing and what they are and aren't consenting to, especially in a space like Slack where people are just having conversations. And it's not clear that they want everything they say to be surveilled. And so creating a mechanism through which that is filtered and toned down so that people can have more confidence in this system and make their own choices about what actually gets into this system. There's also an interesting phenomena that this system feeds back on itself, because the chatbot acts in Slack and Slack is sensed, so it sees its own past, and we have not totally figured out how to study that yet. I think it's really interesting. I think there's no way around that as an important factor, but I can say we don't really know what the consequences of that are. So that is actually, I believe, the last slide.